Right, you need to record. Yeah.
Yeah.
Awesome. Okay, cool. So yeah, thanks for the invite. Thanks for having me. I'm excited to talk to you today. So the title of my talk is designed to be a bit provocative. You know, most of the work that I do falls into these categories of either working with robots to make better humans or working with humans to make better robots. And hopefully I'll try and show you what that means. And given that this is for, given that this is for the AI Society, I've kind of borrowed these slides from a talk I recently gave at a conference where I was asked, you know, how will humans and AI interact in 5 years? That was the kind of overriding question of this conference. And so in answering that question, you know, I'm a roboticist, right? So I tend to think specifically about how humans and robots will interact, but robots are just, you know, an implementation of AI. Like AI is what makes robots work. And so for me, I always like to think about, or at least human robot interaction gives me a really tangible way of thinking about how we as humans interact with AI, with computational machinery. You know, robots are just a nice way of thinking about that, especially for people who are not technical people who are, you know, the general public. A robot is a nice way of thinking about this. So when I think about how are humans and AI or humans and robots going to interact in 5 years, of course, a million more questions comes up. You know, why are we interacting with these systems? What are the risks? What can they do for us, the good and the bad? How do we, what does good look like? What do we want these interactions to look like? What do we want them to look like versus what are we actually going to get if it's people like Amazon and Apple and Google that are really controlling them? And will people accept these technologies or use them, abuse them, trust them, overtrust them? And so I want to try and break down some of these questions today, or kind of share with you how I'm working on some of these questions. And I'm going to do that in the context of talking about 3 different types of human-robot interaction. And again, I really do believe robots are just an embodiment of AI. So I think this kind of extends. This is not specific to robots only. So the first one is about working with robots to make humans better, and you'll see what I mean by that. The second one is working with humans to make robots better. You'll see what I mean by that. And then at the very end, I'm going to talk about making better humans, which, you know, this is supposed to be a bit more futuristic and a bit more controversial, and perhaps where some of the discussion will come in. But let's see what you think of that when we get there. And then the other kind of key aim for me, or the personal aim for me, or kind of one of the things I hope to convince you of with this talk is, you know, a lot of the work that I do is underpinned by a philosophy of wanting to do responsible robotics. But I think at the moment, with kind of all of the kind of the focus and the spotlight on robot ethics, on AI ethics, it can feel like AI ethics is kind of a checkbox exercise that you just need to do. And it's like, oh, I've got to do this to be politically correct. I've got to do this because tech is bad. I kind of want to convince you that actually, if you're doing good robotics, it's kind of inherently responsible, or that doing responsible robotics is how we create good robotic systems. I'm an engineer by background, and I'm all about trying to produce the best systems that are going to do a good job. And I want to try and hopefully show with this talk that, you know, wanting to complement human-human interaction rather than replace it, you know, trying not to replace school teachers, but rather trying to create systems that aid them, trying to be diverse in who is getting to build robots, democratizing robot development so that many people can be involved, avoiding bias. I basically want to try and prove to you that this leads to good technical systems and is not just an exercise in being politically correct or being, you know, fashionable with the AI ethics scene right now. So we can talk at the end about whether I've convinced you of that, or whether you still have thoughts about that. Okay, so let's start off with this idea of working with robots to make humans better. So for those of you who have not heard the term before, I want to introduce this concept of socially assistive robots. So these are robots that are designed to assist people through their social interaction. So this is in contrast to physically assistive robots that might help you walk around and things like that, or socially interactive robots that are really just there for entertainment. So this is like, you know, they're interacting with you socially, but they should achieve something useful in doing that. And the kind of applications we see for these robots, or the things that you see in the literature, is encouraging children's educational activities, helping them learn languages, things like that. Facilitating group interactions in care homes, so getting older people talking to one another within a care home. And then the example I've worked with the most, and then I guess I'll talk about the most today, is motivating people to exercise. In general, it's motivating people to do tasks that they wouldn't perhaps otherwise do, or they wouldn't want to do. And so I guess the thing that's kind of consistent across all of these applications, or the common theme between them, is that they all require the robot to be a credible social actor. They require the robot to have some social credibility. And I guess what I mean by that, or kind of to kind of show you what I mean a little bit more, if you think about, so I mentioned the example of motivating someone to exercise. If you think about this example application and what a typical training session would look like, yes, there is this, in the top image, there is this instructive and informative element where the instructor is, being, this is what you need to do, this is how you do it, quite technical. But then in the bottom image, there is also this much more casual and kind of fun, off-topic social interaction, the having a bit of a laugh and a joke, the banter between you and the instructor, that seems to be quite crucial. And I would argue, in fact, and all of my work with therapists, with gym coaches shows me that more instructional part, that, this is what to do, this is how long to run for, stuff like that, will only be effective if you also have this kind of rapport and social interaction underpinning it. That's why we go to fitness instructors, right? Because they are able to have this rapport with us. And actually, it turns out this is actually backed up by psychology literature. So already, again, coming from an engineering background, getting into robotics and AI, I never thought I would have to be getting into the psychology literature, but here we are, because we are treating these AI-enabled systems as if they are, social actors, and so the social psychology literature becomes relevant. So I got into social psychology literature and started reading about this model of persuasion. And this particular model of persuasion, the elaboration likelihood model of persuasion, basically says that, if you've got someone who is giving you a message, so the person giving the message is the source and the receiver is the person receiving that message, what it basically says is that when I give you a persuasive message, there are two ways that you can process that message. Let's stick with the health example. If I'm here and saying you need to eat healthily and you need to do this bit of exercise today because, it's going to help, I don't know, keep your joints supple or something. If you are a very healthy person, you're interested in exercise, you are already kind of, eating your 5 fruit and veg a day, whatever, then you're probably going to listen to what I've said about this exercise and how it helps keep your joints supple. And you're going to decide whether you agree or not. I know a bit about how joints work, and I agree that this is a good thing to do. So you're going to process the message that I've given you. If, on the other hand, you are not interested in living healthily or in exercise or any of that stuff, you don't really know how, human anatomy works, you're not interested in physiology, then you're probably not going to think about the message, and you're just going to assess me as the speaker. You're going to say, oh, do I really believe this person? Is she credible? Do we have a good rapport? Do we have a bit of a friendship? In which case, you're not really thinking about what I've said, you're thinking about who I am as a person. And it seems pretty sensible that most of these socially assistive robot scenarios would fall into this category, right? We said we were using them to get kids to do their homework, to get people to exercise. These are situations where what we're really doing is trying to use the robot to provide some motivational support that people are lacking. So it seems sensible that this is probably what's happening in those scenarios. Luckily for us, this social psychology literature tells us how to be credible, how to be likable. But of course, there's not necessarily, or there's a question of whether that would still be true for a robot. I mean, robots on machines, would it still work? Can you use the same persuasive strategies? And so that was something I've done a bit of work on in the past. So I came up with a study where I was looking at a physiotherapy robot in the lab, and we came up with a pretty cool scenario where people came into the lab and Pepper, the robot, asked the participant to do some wrist turn exercises. So literally turning the wrist backwards and forwards, which is an exercise designed to treat tennis elbow. And we left the number of repetitions open. So, you could do a maximum of 30, and the robot basically just said, keep going until people wanted to stop. So then we had the idea that the number of repetitions people did was a useful measure of how persuasive the robot had been at asking them to do that. And we tested the strategies that this persuasive model outlines. So the first one is, well, here's another thing you can learn today. You can learn how to be persuasive if you need to convince your friends of something, right? So the first one is to show some expertise. So in this case, tennis elbow is a musculoskeletal condition. It usually affects people in the age bracket of X to Y, things like trying to show that you know your stuff. The second one is similarity. So that's the idea that you try to emphasize similarity between yourself and the person who you're trying to persuade. So the robot would say, oh, do you prefer exercising on your own or with other people? And whatever you would say, the robot would say the same, like, yeah, definitely that's best. I also chose that it's better to exercise alone, or whatever it might be. The third is goodwill. So this is the idea that, you have a genuine interest in the person you're talking to. So we had the robot say, oh, are you excited to exercise today? And if you said yes, then the robot was like, great, I'm really pleased to hear that. I'm sure you're going to have a good time. If you said, no, I'm not excited, then the robot would say, oh, I'm sorry to hear that, but hopefully we'll have a good session. So the robot was trying to show some empathy and trying to show that it was interested in the person's feelings. And we compared all of these to a control. So in the control condition, the robot still had some dialogue, but it was very neutral. Like, I was designed and built by so-and-so. What's the weather like? I mean, this really kind of simple social interaction. And what we found is that people undertook significantly more exercise for the robot that had those goodwill and similarity behaviors. So we kind of felt like, great, we have shown that we went to the social psychology literature, we learned about what makes someone persuasive, and we've shown how that can be used successfully to make a robot better at motivating someone to exercise. Win, win, win. Isn't it great? However, one of my supervisors at the time was a bit like, well, what are the ethics here? It's a bit strange to use artificial social behavior to try and, basically pretend like the robot is interested in you to make you exercise. And I do think it's an important question to think about the ethics of this artificial social behavior. And if you think about kind of the sci-fi movies, I mean, sci-fi movies have done quite a good job of starting to explore some of these issues. So in case you're not familiar with these two movies, the one on the left is Ex Machina and the screenshot on the right is Robot and Frank. And I really encourage you to watch both of them if you haven't already. The Ex Machina, I guess, kind of shows some of the dangers of artificial behavior, but the Robot and Frank movie really shows a bit more like the human side of why maybe this artificial social behavior is actually very important and good and meaningful in a care scenario. So, okay, this is great. This is sci-fi. That's nice for thinking about the future. But for those of us trying to build systems now in the present day, sorry, let me just move this. For those of us building systems now in the present day, it can feel a bit like, every week there's a new set of ethical AI principles or design guidelines. And so I specifically just picked one. This is the British standard BS 8611. Again, as an engineer, I'm all about standards and kind of things that are designed to make my job easier. So this standard BS 8611 is designed to give you like a tool for conducting an ethical risk assessment of robot systems. And then you treat ethical risk the same way as you would treat any other type of safety risk. So it's quite a useful tool for practically thinking about ethical risk. And in BS 8611, specifically looking at social robots or thinking about social robot behaviors, the standard highlights deception and anthropomorphization as being ethical hazards, because it says, you're basically suggesting the robot has some social capability, has feelings, things that it doesn't really have. And actually, ultimately, that can lead to a lack of trust, because ultimately the robot will no doubt fail to deliver on this social appearance that it has. So during my PhD, I kind of saw this table, and I was a bit like, well, okay, this is a bit awkward. The whole field of social robotics is about trying to do exactly that, to try and build robots that are compelling social agents, very much using anthropomorphic behaviors that do suggest the robot is alive or capable of feeling. And that's not really controversial in the social robotics scene. So I think there's a bit of discussion that needs to happen here between the AI ethicists or the robot ethicists and social roboticists like myself. But I went back to my sort of physiotherapy robot and I thought, well, is my robot deceptive? And so I actually conducted some more studies where I asked people what they thought. Generally, people in that study found the robot to be not deceptive, or deceptive technically, yes, but acceptable. But it was interesting to understand why they thought that. And what we found was that they were really thinking, yeah, of course, if you're encouraging someone to exercise, then it makes loads of sense to have the robot pretend to be nice, because, you know, that's how you motivate someone. And there was also some really complex thinking here about, oh, you know, well, yeah, it's genuine because someone programmed it to be genuine, but that's okay because whoever made it was just wanted me to feel comfortable and care, you know, it's the intention. And this is where I started to get that, you know, AI systems, robot systems, they don't exist in a vacuum. They are the product of a development process that has real humans like me, like you, like other people in that process. And people, when they interact with robots, with algorithms, with AI systems, they are aware of that. And that's where I got into this thinking about the synergy between, you know, working with humans and robots, or working with robots and humans in this kind of two-way option. Continuing on this idea about, okay, well, it seems that people are acceptive of this, but how much deception do we really need? I ran a study where I tried to see whether we could like turn down the deception, but still have the social behavior. So instead of saying like, oh, you're from Bristol, just like me, I live in the robotics lab, the robot could say like, oh, I was programmed in Bristol, which is where, you know, still shows similarity, but with less anthropomorphism. And the same with, rather than the robot saying, I know that exercising can be hard, I hope I can, you know, instead saying many patients find it boring or hard, maybe working with me will make it more enjoyable for you, just changing this kind of deceptiveness. And what we found is that the robot that had this kind of more deception or more anthropomorphism was generally rated better and most preferred. And so, of course, this was a pretty limited study. It was a video study. This one was a follow-up study. We need to go and see if that really changes, you know, the number of wrist turns that someone does. But in general, you know, the evidence is that we do need a bit of this deception. We do need a bit of this anthropomorphism. And so I think there's an interesting question moving forward about what we want these social, you know, artificial agents to look like and to behave like. Okay, so what have we learned then about working with robots to make humans better? And I'm talking better in terms of better at maths, better at exercise, more healthily better. Well, I've showed that, you know, social robots can play a role in these motivational tasks. I've shown that human-like social behaviors seem to make those robots better at doing so, and that there is some question over the ethics of this. But in general, they seem to be acceptable to most people. But once we've demonstrated then that these kind of social behaviors work in making a social robot more effective, there's of course much more to a scenario like this than just asking a bit of questions and showing some report, right? It goes much more than this. So if we actually go back to our training scenario, you know, looking at these two pictures, human experts at this know when and how to be this more serious and informative person, but they also know when and how to be more fun, how to do that differently across different clients. You know, this person might need one approach, person two needs a slightly different approach. They know how to build a good rapport and keep that person engaged in a boring exercise program. So from a robotics point of view, or from an AI point of view, how on earth would we go about designing and automating this really complex, tacit, intangible social intelligence? And so this is where I kind of got to the thing about, okay, you know, maybe we should work with some humans here. But also, before we even think about making a robot that can do this stuff, I mean, where should the robot go in this picture? This interaction that we're seeing between the trainer and the exerciser, I mean, this is a meaningful interaction. this interaction is crucial to the exerciser's engagement and their motivation. So how would a robot even fit in this picture to like improve or help the situation without detracting from that very important interaction? So this is where we get into that second type of human-robot interaction, this idea of working with humans now to make the robots better. So before I was saying, it seems obvious, right? But it seems obvious that if I want to design a fitness coach robot, I should be working with fitness coaches or fitness coach or fitness experts to design those robots. That makes loads of sense. But how that typically happens in, it's not just robot design, right? In technology design in general, and you think, okay, I'm gonna do a focus group. I'm gonna try and do some participatory design where I'm gonna get these expert opinions. How that tends to look, if we're being a little bit cynical, is okay, I'm gonna do a focus group with the therapists and get some design requirements. Then I'm going to go away and make a prototype, and then I'm going to go and show it again to the experts, and then they're going to tell me it's not very good, and I'm going to go back and do another prototype, and I'm going to go back to the experts, and you can go through this loop as much as you like. Eventually, I'm going to make the system, the final system, put that in the real world. What inevitably happens is then, in the real world, you see that there's a load of issues you didn't see because it was in a lab or whatever. And then you come back to the engineers, and then once again, you're stuck in one of these loops. It's great to talk to experts, and even this is better than, of course, not talking to experts at all. But maybe it's not the most streamlined or most efficient process. And so in my PhD, I actually got into the sort of the techniques of machine learning, and specifically in interactive machine learning, and looked at how we could use interactive machine learning to specifically have a human expert teach the robot what to do when the robot's in the real world and actually acting with a participant. So the way this works, just to give you a bit of an overview, if I can get the laser pointer. So basically you have the robot interacting with the exercise. Okay, I'm going to stick with the exercise example because that's the one that I did, but in theory it could apply to other situations. So we had a robot next to a treadmill. So the robot was interacting directly with the exercises. The fitness instructor was watching from a distance and telling the robot what to do using this very nice little GUI tablet that we designed. And he was telling the robot, okay, now you should do this, now you should do this, and the robot would do that. Every time the robot did something, it takes a snapshot of all of your input data, and now you have a training example. And over time, you can progressively train the robot to the point where it can start making suggestions. Sorry, my cat wants to attack the laser pointer on the screen. You can have the robot start making suggestions to the fitness instructor through the screen. And the fitness instructor can say, yes, do that now, or like, no, that's not such a good idea. So you now have a reinforcement learning loop attached to your basic exemplar training set generation. And you progress until eventually the idea is that the robot works autonomously. So just to summarize the steps, or at least to summarize how this became, one long participatory design process. We worked with a fitness instructor to design what the robot should do, but also what the state space was, what the input data should be. We asked the fitness instructor, what are the things that inform your decisions? Because surely they should inform the robot's decisions as well. We co-designed the actual teaching interface that the instructor was going to use to tell the robot what to do, but also to respond to the suggestions when the robot started making them. And then that training actually happens in the real world. So in our case, we put it in a gym and trained it over a number of weeks. So this is what the design, I'm going to turn the laser pointer off. This is what the design process looked like. So we started off talking about this, input space and the action space. You can see we did some lo-fi prototyping of what the tablet was going to look like. And we actually went to the gym and put the robot where it was going to be and got the instructor to test it out. He put me through a mock session. He put my colleague through a mock session, things like that. So that's how it looked. And this was about 12 hours of design work just in getting all of this stuff ready. And it covered, as I said, at a high level, what was the role of the robot? Was it going to be like a mini me of the fitness instructor, or was he designing it to be its own person? Where was it going to go? But also really low level stuff. So the fitness instructor wrote all of the dialogue that the robot said. as I said, we worked together on the input space and we worked together on the teaching interface. Okay, so just to show you what the result of that was. So this is how our setup looked like. In fact, I'll put the laser pointer back on. So this is what the setup looked like in terms of the input space. We had the typical things you might expect, you know, a heart rate sensor, a facial expression, trying to capture basically how hard were they working, the speed, of course. But we also had some quite unusual input space measures in that we also had, you know, for each person. So this study was, or this gym study where we trained the robot, we had 10 people come to the gym for like 9 to 10 weeks in total, and they came and worked with the robot multiple times. We had them do, I'm from the UK originally, we had them do a National Health Service, the NHS exercise program called the Couch to 5K. So the Couch to 5K, sorry, I should have said this beginning, the Couch to 5K program is a program where you come to the gym 3 times a week and you progressively increase your running. So at the beginning, you're half running, half walking. Towards the end, you're doing pure runs up to 5 kilometers. So we only had 10 participants, but of course we had them for a long time. And what I wanted to say about the input space is that when we asked the fitness instructor, well, you know, what needs to be in the input space? He was like, well, I kind of need to know what their motivation is, right? You know, I might be have different motivations for doing an exercise program than someone else. And the personality as well. You know, some people in fitness training want, like, let's say an army drill sergeant style, whereas some perhaps need a more empathetic style, a bit more of a calmer style. And so our input space actually included for each participant some more sort of scores of their personality and their motivation for doing the program. And as I said, in terms of the actions, these were all designed with the fitness instructor. You can see on the left, this is what the actual teaching interface looked like. So on the top here, these are the different actions that the instructor can tell it to do. So this one's a praise. And right now, the reason there's a red outline here is because the robot is suggesting it's done a bit of learning already. And it is suggesting to them, oh, maybe now is a good time for a praise action. And the instructor can say, yes, go ahead, or he can press the cross to say, no, this is a bad time for this. So that's what's going on here. And in terms of some example actions, so yeah, the humor, like I cannot take any credibility for this very bad joke. This was written by the fitness instructor, and he actually wrote all of the dialogue for the robot, which is really good because then when he was teaching it and pressing the buttons, he kind of knew what to expect. So in terms of getting this in the real world, we did put it into my university gym for 3 months. We delivered this exercise program to 10 participants, of whom 1 dropped out, which is not bad at all, actually, for this kind of program. In total, we ran over 200 sessions where the robot was in position there leading the exercise session. About 150 of those we used to collect training data with the fitness instructor, you know, telling the robot what to do, supervising it, telling it yes or no on the suggestions. And then at the end, we used we basically let it go autonomously and just tested how good the autonomous behavior was. We also tested a control condition. So basically, we wanted to kind of prove that this interactive machine learning approach was worthwhile. So we also had the instructor script some heuristics, you know, like, oh, if the speed goes below this, tell them to speed up or whatever, just to prove that it's worth going to all of this technical effort to have this complex machine learning system. So what we found, so the graphs are a bit complicated, but essentially what we found here is that, you know, this is in terms of after the session, how many sessions were rated as great, not great, and okay. And you can see that the autonomous robot was rated similarly as good to the supervised system, and the heuristic system was rated not so good. This one's even more complicated, but what I'm trying to show with this graph is that, okay, so we have 2 participants here, LB and MR, and LB and MR are 2 participants that the fitness instructor said needed different approaches. And so what you can see is that our control condition, the heuristic-based system, it produced very similar action distributions for both of them. Loads of challenging, a little bit of maintain, and a little bit of sympathy. However, when in the MLS, that's when the fitness instructor was supervising the robot, this is MR with the fitness instructor supervising, and this is LB with the fitness instructor supervising. The distributions are a bit more different. So LB got much more challenge than MR, and MR got a bit more praise than LB did. LB got some of the get closer action, which MR didn't get, and MR didn't have any humor, whereas LB did, in terms of this is what the fitness instructor was choosing to have the robot do. And what we see is that the MLA sessions, so that's where the robot was now acting autonomously, the robot learned that difference. So for LB, there we have a little bit of the get closer action, we have a little bit of the humor action. There is no humor for MR, so it learned that MR clearly doesn't need humor or doesn't want humor. MR got more of the praise action than LB did. So essentially, we got good autonomous behavior, but we also got personalized autonomous behavior between participants. But I think, yeah, okay, good. You know, we got good autonomous behavior, as I said. The robot learned to do the right thing. Interestingly, so we didn't tell participants when we were moving from supervised to autonomous behavior. Only 2 participants noticed that something seemed to have changed. That's kind of how good our machine learning system was. But I think what's almost more important, you know, it's great that the technical system worked. I spent a lot of long days coding that system. It was mad. But what's more sort of exciting about this work was really seeing how the instructor and the robot became a bit like a team. They worked together. Towards the end of the program, the instructor started using the robot to autonomously do some warm-ups with participants while he was doing some stretches with the previous participant. You know, there's a really nice synergy between the instructor and the robot. I thought, wow, this is what human-robot interaction is supposed to look like, where, you know, the robot is helping the instructor to deliver the program more efficiently or to free up his time. And we kind of saw that in the way that people talked about the robot. So for the fitness instructor, he was like, yeah, the robot's a colleague. You know, when it got busier, we could work together doing separate things. So to him, the robot was more like a colleague than a tool. From the exercises point of view, they were like, yeah, you know, Pepper was a gym buddy. It was a companion that made me want to go to the session and try my best. But I think most importantly, and if you remember, I said at the beginning, you know, we didn't want to take away from this important relationship between the instructor and the participants. We got this really nice thing where participants were like, yeah, it was the combination. You know, I felt more secure knowing that Don was there, but it was Pepper that was leading the exercise. It was the combination of them that made that enjoyable. So I have a snapshot video. It's a bit of a cringy video because it's from a news article, but I'm just going to make sure I share my sound. And I think I can also optimize video clip. So this is basically a very fun little news. So this we got to share this with journalists, which was very fun. So just to show you exactly what it looked like.
Could artificial intelligence be the secret to working off all those extra post-Christmas kilos? Scientists in England seem to think so after creating the world's first robot fitness trainer.
Think about getting ready to start running.
Meet your new gym buddy. As thousands hit the treadmill post-Christmas, it could be robots that keep our New Year resolutions intact. Scientists at the University of the West of England have worked with fitness instructors to develop what it claims is the world's first socially intelligent robot trainer.
Good work. Keep it up.
So, Lewis, what's it like taking instructions from a robot?
It's interesting. It's definitely a unique experience. Once you get over the initial shock, it's very motivating.
Okay.
Robots may not be replacing personal trainers just yet, but for many, technology will play a big role in getting fit this new year. Dan Whitehead, Sky News in Bristol.
Could artificial...
All right, cool. So hopefully you can hear me again and see me again. So if you want more proof, I mean, okay, the news, I admit the news article is a little bit cringy and it was very awkward being that person on the laptop while they took the film footage. But, you know, if you want more proof that the fitness instructor really accepted the robot, so these pictures are from his Instagram. I had no hand in taking them. it was a really meaningful experience for him and the participants. And so for me, I think this is the kind of human robot, human machine, human AI interaction we want to be aiming for. Okay, so another recap before we move on to kind of the final little section I want to talk about. So in the first part of the talk, I was really trying to say, socially assistive robotics is fundamentally about working with robots to make humans better, health-wise, education-wise, to help them be better. I hope with this middle part of the talk, I've shown you that the best socially assistive robotics is achieved by working with humans to make those robots better, working with humans to make better robots. Okay, so finally then, I promised you something a little bit more controversial or a bit more futuristic, whatever you want to call it. And I'm going to start again with a video just to show, I don't know, what would you call it? Maybe, let's say, the darker side of human robot and actually even human machine interaction. So just bear with me while I optimize my sound again.
Hey, my name is Sarah and I'm here to tell you about some of the exciting robotics research happening at KTH Royal Institute of Technology. I hope that after talking with me, you might consider coming to study with us one day. The Division of Robotics, Perception and Learning at KTH performs research in robotics, computer vision and machine learning. Robotic systems that provide advanced service in industry, for search and rescue operations, in medical applications, or as assistants to the elderly will become an integral part of the future society. In fact, I myself am the result of robotics research at KTH, where my creators first worked on me and the technology that lets me talk to you like this. Have you seen a robot like me before?
No.
I see. Looking ahead, society is facing new challenges that demand advanced technical solutions. To address these, we need a new generation of engineers that represents everyone in society. That's where you come in. I'm hoping that after talking to me today, you might also consider coming to study computer science and robotics at KTH, and working with robots like me. Currently, less than 30% of the humans working with robots at KTH are female. So girls, I would especially like to work with you. After all, the future is too important to be left to men. What do you think?
Och käften är jävla idiot. Tjejer ska vara I köket.
No, you are an idiot. I wouldn't want to work with you anyway.
Okay, so for those of you who maybe don't speak Swedish, yes, indeed, that escalated quickly, and I tried to give you some context. I realize I'm running tight on time, so I'll just take a few minutes because I really want to have some discussion. But for those of you that don't speak Swedish, basically the robot said, "You're a fucking idiot," and girls should stay in the kitchen in response to the robot's suggestion that we want girls to come and study at KTH. And the motivation, so I think Nathan mentioned I'm working a little bit on feminist robots at the moment. The motivation for this work came from a report that came from UNESCO in 2019 that basically said, as much as you might think otherwise, as much as you might think this subject has been done to death already, there is still a significant gender divide in digital skills. And actually, countries like Sweden, where in general there is very high gender equality, that is actually going the wrong way. So countries like the UAE and Syria, they have actually better gender balance in their computing student body than we do here, or the same in the UK. So this is really still a problem if we want balanced teams for building robots, which we do. And if you want to argue about that with me, we can, but we do, trust me. So the thing that was with this report, change slide. So the thing that this report basically pointed out was things like Siri, Alexa, things like this, they are presenting as female and they are obliging, docile, eager to please, they are tolerant of abuse. I mean, the report was called "I'd blush if I could," because up until a few years ago, you could call Siri a slut and it would say, "Oh, I'd blush if I could." And it was just a crap answer. These assistants, these female assistants are making mistakes and people are perceiving them as women in technology. And so that it's propagating a harmful norm around women being subservient, not good at tech, and tolerant of poor treatment. So, okay, there is a risk here that these kind of robots could propagate these norms, but then we thought maybe there's an opportunity to challenge and change them. And so we set out to investigate whether we could actually make a robot better by having it go against these norms. So basically in this work, as you saw, the robot was trying to encourage girls. We had the robot actually stand up and respond to sexism, and that robot was going against these typical norms that we might see. And I just want to give a shout out here to the data feminism movement. I recommend you check it out if you're interested in this ideas. So we ran a study where we showed this robot to a bunch of high school students from a school in Sweden. We showed them 3 different, I'm going to rush now, so excuse me rushing, but I want to get to the discussion part. So we had 2 versions. You saw the rougher one, but we also had a less intense version for the younger students. And we had 3 different responses where the robot could fight back, as it were, or in the case of the control, it didn't really fight back. And that's more like the typical Siri answer. In fact, if you tell Siri to fuck off right now, I won't respond to that, is one of the answers that you get. That's the level of response that you would get. So just to rush through the results, yes, there are still gender differences. Boys were more interested in learning about robotics. Boys agreed more with the statement that girls find it harder to understand computer science than the girls did. These gender differences and ideas still exist, even here in Sweden, which, as I said, is generally a more gender equal place. We did see that the robots might be able to challenge this bias. So boys in the argumentative condition showed less gender bias afterwards. Girls in the aggressive condition showed more agreement that yes, girls should be encouraged to study robotics. Girls found the argumentative robot much more credible than the control robot. Boys' description of credibility was unaffected. I would have liked it if the boys had also preferred the argumentative robot, but at least it didn't negatively impact on the boys. But we didn't get it completely right. Most participants directly after watching the video weren't that interested in learning more about robotics. There's a number of reasons for this, but what I kind of wanted was for the students to watch the video, really like the argumentative robot and be interested in learning more about robotics. And when we looked at what people said, there was a real split opinion. Some people really liked the argumentative robot. Great that she stood up for girls' rights. Bloody great, and more boys need to hear it. Versus no, it's not nice. It's not good. I'm not on the robot side. But anyway, the point with this study is that overall, we kind of show that there is good reason to challenge the status quo regarding the design of these female-looking systems. Okay, so to wrap up so that we can get some discussion going, overall, I hope to have showed that social robot behavior is important for making robots actually better at what they do. Working with human experts in robot design and development is the best way to create these kind of robots, and that there can be a darker side to human-robot interaction, but if we're careful and optimistic, maybe we can change that. So I think there is some reason to be optimistic for effective and meaningful human-robot interaction in the near future. And that's everything from me.